Right, so you go to sign in with an existing account, which you can create your own account, but if you sign in with Google, you're good to go. All right, so I signed in with Google. I have extra stuff here open that I don't need. All right, so we want to go to geogebra.org/graphing. There's different variations. You have the classic apps, you have other types of apps, but if you click on the waffle here, you have graphing calculator, geometry, 3D graphing, that's Calc 3, and then the classic one, which is very powerful. It's just not as user-friendly as the one that I want you in, which is the graphing calculator. So if you had to guess on which one you were going to do, it's probably going to be this as your guess anyway. So I don't like the little graph grid here. You might do. You could leave it on if you want, but if you right-click, you have the option to show grid. I don't like the grid. I like a nice, clean, white workspace. That's a personal preference. It's not a requirement. All right. So what we want to do is we want Geogebra to figure out derivatives for us. Geogebra will do it. Geogebra will do it analytically, so meaning it'll give you the equation of your derivative, but it'll also do it numerically, so it'll tell you the slope at a particular point. Right? If you wanted to evaluate points for you nice and neatly and conveniently, creating a slider is a good way to go. All right, so what I would do, let me just get rid of this, I need that. You just start typing in a constant. I want a constant C, anything in the beginning of the alphabet. You just type it in, so I'll hit C. It gives you the option to create a slider. Just click Create Slider. So now I can slide back and forth and allow C to be a variety of values on whatever interval I define. All right. If I click on either of the endpoints, I can manipulate this. I can make it go -10 to 10 if I want. I could have it skip along if I wanted to only go by integer values. I'll just put in a 1 for step. But that's beyond what I need. All right. So I didn't save anything. I just keep it at the -5 to 5. But you can play around with that. It's kind of interesting. All right. So if you're exploring this on your own, you would type in whatever transcendental function you wanted. So again, that's just the non-algebraic stuff. Trig, exponentials, logs, anything that transcends normal algebra. That's why I call it that. I'm going with exponential e. All right, so all I'm going to do is type in f of x equals e to the x. All right, the little toolbar down here, you have your little power function, stuff like that. I just type it in manually, E, and then the caret symbol, Shift 6. It doesn't actually bring up a caret, it actually just makes it an exponent. Just type in the x, right arrow, hit enter. If you click on special points, it'll give you anything in a calculus class that you would determine to be special. So what's special? Things like roots, extreme values, mins and maxes, things like that. So, just think back to Calc 1 and where I asked you to find a relative max or min. If I clicked on special points, it would give me every relative extremum that exists on whatever interval that I'm showing, and also the roots, absolute max and min. It's wonderful. All right. So I have my function. This looks very much like an exponential base e. If I scroll this back and forth, it's not doing anything because I haven't asked it to do anything with that. All right. So let's go back to the assignment. What I want are my derivatives. I want the first, second, and third derivative. You can go to the 1,000,000th derivative if you want, and it'll take a long time, but you can get there. All I'm going to do is find g of x as the first derivative of f of x. So g of x is equal to the first derivative of f of x. You can put the x in if you want. It actually doesn't matter if you don't. All right. Now, the derivative of e to the x is e to the x. So it doesn't appear that there's anything new here, but there is. These closed circles here, if I unclick them both, graph goes away. This is my derivative graph. And there's my original function graph. So they're all there. They're just overlapping each other. It'll be different when you involve other types of functions. So I want my second derivative, which is going to be the first derivative of the g function. Right? Finding higher order derivatives in other ways is such a royal pain that it's just worth doing it this way. First derivatives of your new function, right? Nothing new here because my second derivative, my third derivative, my 14th derivative, they're all going to be e to the x. I want one more. I of x is equal to h prime of x. So I of x is equal to h prime of x. All right, so all the same. Why are we doing this? Well, to torture you, obviously. This is the Taylor polynomial, or at least in its infancy. We'll expand upon this, but this is the recipe for taking a transcendental function and writing it as a polynomial function. If you follow this model, you'll be able to do that. But you can see here, we start off with evaluating the function as is. Then we evaluate the first derivative at a particular point. Then the second derivative. Then the third derivative. You can go as far out as you want to the nth derivative. Well, what's n? Well, it all depends. And in fact, one of the reasons why we're doing this is to see whether or not going out very far in the Taylor polynomial will impact the quality of your graph. Right? And you'll see. I mean, spoiler, there it is. Let's do it that way. So, terms of the Taylor polynomials, all I did was I kind of itemized it. First term, first two terms, first three terms, and so on. I only want to go out as far as the third derivative. You can go out further if you want. It's just, after a certain point, it's like, you get the idea, so why are we wasting our time? So, f of c. I'll write it as a equals f of c. All right, so what this just did was it plugged in whatever I have for c into my f function. So now if I scroll back and forth, you could see that it's changing this calculation depending on whatever c is. All right, so if it's equal to 3, for example, I can't seem to get it on to 3. Oh, I had it for a second. It's terrible. I can't really do it. Just click up here and just type in the 3. All right. So if you want to get it to a particular value, just click up into that field and just type in the number that you want. All right. So that's the first part. Then I want p of x, because I want to name these things, because otherwise Geogebra is going to name it for you. If you don't name it, it names it. And then you lose control over the naming. And then you could lose control over the different pieces. And you'll find yourself getting frustrated. All right, so this is telling me that I want f of c plus f prime of c times x minus c. Well, my f prime of c would be g of c, because g of x is f prime of x. So I want to type this in to amount to really whatever this is saying. So my a is the f of c, which is nice because then I don't have to write f of c. So p of x equals a plus g of c times x minus c. All right, I'm going to do a split screen action here, I think. And where are you? It's the other one. This one. Oh, there it is. And then let me just do... I don't think I need this the way it was. I want to kind of clean this up. Click on that. All right, there we go. All right, so just following the progression here. A plus g of c times x minus c. All right, now all of that I called p of x. So now instead of writing all that stuff again or duplicating it, there is a duplicate button. if I hit the three dots here on any of these, it'll duplicate whatever that calculation is. I don't want to do that. I just want to, if I know that P of X is that last component, I can just build off of that. So Q of X would be equal to P of X, so my previous answer, plus the next term of my Taylor polynomial. So I want 1 over 2 factorial. So 1, hit the division key, and it'll automatically make it into a fraction. 2 factorial, exclamation point on your keyboard. H of C. Sometimes I get a little nervous, so I'll hit the times key. You can do it here if you want, and then put the H of C. It usually doesn't amount to anything, but when I mess it up royally. So X minus C squared. All right, so that's the next term of the polynomial. All right, so looking at what I have here in the graph, I could zoom out just by rolling my mouse. I get this on there, it looks like a line. That looks like a parabola, even though it didn't really look like that a second ago, but on this interval, they're kind of matching up. All right, so that's pretty interesting. Okay, I wonder if there's something to that. So the next part is just adding in the next component. So Q of X is all of this stuff, from F of C all the way through to the 1 over 2 factorial business. So I just got to take that answer, I'm going to call it R of X. And then we're going to have 1 divided by 3 factorial. Oops, you can't see it. Multiplied by I of C. So I of C. That's my third derivative. Times X minus C raised to the third power. All right. Oh, forgot. Well, I knew what it was supposed to look like, so I knew I made a mistake. I forgot to put the Q of X in there. Plus that. All right. So now I have everything I need based on calculations. I did everything they asked me to. Now I got to kind of answer it. Now use a slider to visually determine which values of C will allow your models, quote-unquote models, well, not really quote-unquote, but it's we have 3 models, so you need to most closely approximate the given function, and which one is the most precise regardless of C and Y, right? Now your answer here is going to be pretty much the same. I'm kind of giving it to you, regardless of what function you put in, okay? So let me just get a better viewing window here. Settings, that little whatever it is, sprocket, or I don't even know what it's called. Settings, then you can manipulate your window. I don't need to go out to -25 in X, I'll go to like 0. Maybe go to, actually I'll keep it consistent with this. I'll go -5 to 5. And it'll manipulate the Y's also. But as it turns out, we're pretty much good here. Sorry, I'm just checking my messages to see if she indicated that she'd be leaving early for any reason. No, nothing there. I guess I no longer held her interest. Ooh. No. He'll post it up online later on, or will he? We'll see. So anyway, oh, look at this. They slide back and forth. A lot of stuff going on here. So At some point, though, it looks like, and it's very important that you keep track of what the original is, because I don't need my derivative graphs to show up anymore. What I really need are my three levels of the Taylor polynomial. All right, the one where I go out to one derivative, my first derivative, my second, and my third derivative, and comparing that to the original function. All right, so that kind of thins out the mix a little bit. So as you scroll around, and you could kind of dial it out a little bit, you start to notice that it does seem to become more and more accurate as a model for particular values of C. The idea is to figure out under what circumstances you get the most accuracy. Now, I think it's a pretty safe bet that the further you go out in terms of derivatives, the closer it's going to be to approximation. Like that blue one, as I get further and further away from that intersection point, I mean, that's nowhere near accurate, right? So I can get rid of that. The red one, it's better than the blue one, but it's not as good as the orange one. So let's just focus on the orange one. So like right around here, maybe? It looks like it comfortably merges in together, at least around this one. Now, if I can make it, like, let's say a 0. It looks like they're pretty consistent there also. All right, so it seems that there is a relationship between the value of C, whatever I'm calling C, here's 5, for example, and the closeness of the original function and its Taylor approximate. All right, so that seems to be at least a starting point, because if I make this a, let's say, a -2, and then really kind of bring it in, around -2, it's almost indistinguishable. It isn't until you get beyond -1 to the right and -3 to the left that it starts moving away from being kind of a spot-on approximation. Okay? So I think I just kind of gave it to you. Hopefully that's enough for you to work with. Now, your job is to do this for the sine of x cosine of x, and the natural log of x minus 3. That sounds terrible, because what I need from you is a link for each of the GeoGebra applets that you create. All right, so what I would do here is I would save this, click on the little hamburger, I think is what they call it. I don't know. Save it as whatever you want, doesn't matter, and then share. It'll give you, I don't want this link, I don't even know why that popped up. I want this link, the GeoGebra link. Copy it right in here. I mean, this is not for the same one, but you'd copy it right in here. Oh, that's the point, because I don't actually want you putting it in here. What I want you to do is make a copy of this, although I do need to sign in. Make a copy of it. Don't leave it with this title, because then I'm going to have everybody submitting the same. It's just, I mean, copy of last name. Is that your last name? No. Put your last name in. Everything else I think is fine. I would like you to indicate what semester it is, because I use this for multiple semesters. So fall 2018, I believe. So your last name and the semester, that's all you need. And then you put in your GeoGebra link, just paste it right in there, and write your answers to the questions. This link should correspond to this function. Well, it doesn't. So what do I do? Well, this is what I do. I go right back here, and I change my function. Everything else after that is going to be based off of this function. It changes systematically to work with that function. the link will not change. So what you want to do is save it as a new file, and then give me the link for that new file. So I still don't know why that pops up. I don't want this one. I don't want the, oh, it's still saving? Oh. Well, I want this. Oh. Well, when you click on share, maybe I'm hitting the wrong thing. Share, it should be that. Yeah, I must have clicked on the other thing I saw. Copy, pop it right in. All right. So this would be for the sign of X. So once you do it once, you're good, because then I go in, I change it. I don't need this anymore. Change it to X cosine X. Well, don't delete too much. It'll change everything beyond that, assuming you type it incorrectly. Put the multiplication symbol in. I don't know why. Sometimes, like if you write an X cosine X without writing the multiplication symbol in between. What's that? Say that one more time. Oh, okay. It thinks they're all constants. That's exactly what's going on. It gets confused. But anyway, save it as a new file, something unique, and then give me the link, paste it right in. Write your answers to the thought-provoking questions, and then just go from there. All right, so once you do it the first time, it's very easy to finish up after that.